All right, we have 3.8 on our hands, and we have to do question number 9. This is the word problem, and it's talking about this whole concept, remember, of composition of functions. That means you sort of have one function inside another function. This is what this is all talking about. And so as we're going to, primarily this one right here, the training heart rate, notice it has like this, it's T of M and R. So the training heart rate is a function of maximum heart rate and resting heart rate. And so as we look at stuff here, there's a formula now for maximum heart rate. It is 220 minus X. Then we've got to think about what in the world is resting heart rate. We'll sort of see that maybe that is given already here. So let me go to a worksheet that I can work with here. All right, let's look at this here. So use the following formulas. Talked about that already here. So this is like a formula within a formula. It's particularly right here. It's training heart rate is made up of maximum heart rate and resting, right? Okay, but before we get to that formula, we have this one here. It just says find the maximum heartbeat for a person of a particular age. As we look on here, it's really just this right here. There it is. We're just going to write it exactly down. So notice even the formula itself is m of x and m of x. So this would be 210 minus x. Okay, let's move to part B. Part B now talks about what's the maximum heart rate for a 23-year-old. Okay, so again, the formula from part A, or from just this piece right here. Now I actually have to calculate. So there's my formula. It's going to be m of 23. So 220 minus 23. If that's the case, that's going to give us maybe like 197, I would imagine. Because it's 23 away from 20. Okay, so with that will be 197. Looking at part C now. We're going to look at, let's see, what is a training heart rate? That's the one that we really want to get to in this whole composition of functions. It's this formula right here. And again, we're dealing with composition of functions. We're talking about a function that's within another function. So it's T. The training heartbeat rate or heart rate is a function of the maximized and resting at the same time. And the formula goes like R plus 0.6. And it's the difference between maximized and resting. All right, so for a 23-year-old, the resting heart rate is actually just a particular number. It's just 60. Okay, and then maximized, well, we remember that from part B, but if we wanted to, we can sort of just do that again, just real quick here. It's going to be 220 minus 23, and we got 197 for it. So it'll be 197 minus 60. Cool. And then we just go from there. At that point, we just need to finish it off. All right, 197 minus 60 is 137. That'll be good enough there. Now we need 137 times 0.6. Let's see, 7 times 6 is 42. That's going to be 18, 19, 20, 21, 22. And that's going to be an 8. So one decimal place accuracy here gets to a 60 plus 82.2. All right, and adding those up, let's see, that's going to be 142.2. There it is. So this whole concept, though, if you think what the concept is, this part right here, is that you have two functions that are actually embedded within another function. That's the whole concept of composition of functions here. So part C, there it is. Part D, what we have here, really the difference is just the years change, that's all. But everything else remains the same. So with this here, again, writing down the formula here, training heart rate is a function of maximized and resting. resting plus 0.6 of maximized minus resting. And so for a 35-year-old, resting heart rate is 60. And I'm not sure if that's really true. Resting heart rate, I think it was resting heart rate, I think, is close to 70 and not 60. But we got this M value. Here's our problem. M value is 35. It should be M of 35. So we need to plug in 35 into there. So it'd be 220 minus 35. So a little bit of work there. Actually, let me go with minusing that out. 5 looks like 185. And then we're going to subtract 60 from that. So 125. All right, and then multiply 125 times 0.6. All right, and let's see, that's going to be 30. That's going to be 12, 13, 14, 15. 7 with 1 decimal point accuracy, so 75. Added that together, how about 135? And again, kind of makes sense here. Resting heart rate is 60. The maximized heart rate is 185. So training is 125. No, sorry, 135. That's what we want to get to here. Okay, so again, C, D, and E, they're all really the same type of problem here. We're just going to change the years on the person here. So for E, now we've got a 43-year-old. And writing down the formula again real quickly here. This is R plus 0.6, function within a function. And resting heart rate is 60. And so for a 43-year-old, it's going to be 220 minus 43. Actually have to do that on the side there. That's just going to be a 7. That's going to be, looks like a 7-1. So 177 minus 60. So 117 then, as you subtract that out. All right, then we have to multiply these guys together here. So 117 multiplied by 0.6, let's see, 42. And now about 10 and a 7 with 1 decimal place here. So then that's going to be 130.2. And again, that does make sense. It's between 177 and 60. All right, so let's go ahead and let's go back to our problem on it. And let's plug in those values. All right, so let's see. For the function for maximized value, it's just right there. We're going to copy that down exactly how it is, 220 minus x. I'll preview it just to make sure it works for the 23-year-old as we plug in the value there. For 23, it's 220 minus 23. And I figured it was 197. All right, then there's parts C, D, and E. Again, all of them are the same except the age is different here. So let's get those numbers included and let's see what happens. All right, for C, I believe it was 142.2. So we got for that. For part D, I think it was exactly 135. And part E, I believe it was 130.2. All right, that was a long problem here, but let's see if we got it right. Yes, okay, you're like green all the way around over there, so hopefully your problem is going to be very similar to this one. and I wish you well.